Hey everybody, welcome back to another video. In this one, I want to dive into a trick that I got taught back in the day when I was learning TypeScript. It was a senior software engineer that showed me this, and it absolutely blew my mind because of how simple and yet extremely useful it is, to the point that I literally use it every day when I work with objects. So what you can see here is a very simple piece of code. We only have an object with two values and a metadata that is potentially a string or undefined. This is a fairly common use case where you have optional fields in an object that matter whether they have a value or not. Metadata, for example, is very typically a field that if it's not set or set to undefined, it will clear any other metadata that was previously there. But if it's not included in the object, then whatever value was already there is respected. So how would you go about trying to include this metadata only if it has a value? Say if it's undefined, then we don't want to include it into this object because we know this will clear whatever was already there. We don't want that. We only want to add this hello or this metadata constant if it has something in it, right? And this is a very simple case, but let's say, okay, we have that. So if you want it to do that, you would usually have to do this with an if, check if it has a value, and then only then add it. Some people may say, oh, but why don't you use a literal? Well, TypeScript complains. You'll get the property does not exist because an object has already been set as a constant here. You could do something like this and then, okay, we're fine, right? And then it doesn't complain anymore. Sure, fine. But as you can see, this requires first changing the shape of object, right? So the type matches that, and also checking here. And this is just for one field. What if you had multiple fields? Are you going to add a whole bunch of ifs? This becomes quite a bit of a mess. So let me show you the better way. Okay, here it is. There you go. What I like to call the conditional spread operator. And I know you may be thinking, Busker, just what the is that? Don't worry, let me walk you through it and you'll see that it's a lot simpler than it looks. Okay, let's start all the way at the end. All we're doing here is creating a new object with metadata as the sole key, and whatever this value of metadata is, we'll have it, right? So it's metadata and whatever the value is. The ampersand operator acts as a chain of effects or a chain of evaluations. And what it does in TypeScript and JavaScript specifically is it returns the last bit of that chain. In cases where you're doing it as an if, it basically turns it to a boolean automatically and it checks if that boolean is truthy or falsy. However, in this case, what we're doing is, hey, check first if this value is a truthy. If it is, return this. And to this object, we're just applying a spread. And all of that obviously has to be within a bigger spread because otherwise we wouldn't be able to append it to the existing object. This comes at the cost of that extra iteration of the entire object that we already had. And if it's too large, do not do this because you could run out of memory. However, for the vast majority of objects that you'll be handling, this is probably perfectly fine. So that's it. All we're doing is creating a new object from the previous one that we already had and overriding any, if it had, in this case it doesn't, but if it had any metadata values here, we would be overwriting them. What this is evaluating now is if this metadata is truthy or falsy and adding it or not based on that. So we're never going to be able to get metadata undefined. It's always going to be metadata with a truthy value or nothing at all. And if I run this, you can see that because metadata here is a falsy value, right? It's an empty string. We're not including it in the final result. If you did want to include empty strings, right, just do this, and this will check for undefined or nulls. That's what the single equality does. And in this case, there it is, included. And if this had an actual value, let's say whatever, sorry for that, there we go, right, this is still included. This is a fantastic way to check and add only if the value fulfills a condition that we already want. So it's doing almost the same as that if block was doing before, but it reduces it to this single expression instead of all those ifs that we would have needed to do. Plus, the overhead of having to do a spread on the existing object is minimized if you add more of these, right? Every time that you do one of those, you're iterating over a single key object. It's fine. It's not going to be a performance hit, but you can add multiple of those. You could have another same thing, right? And we keep checking for multiple things, and it's all within the same, say, operation, which makes it so much easier to read than having a whole bunch of ifs and adding based on that. I think this is so much cleaner and so much nicer to look at. in my opinion. Obviously, I'm terribly biased, but this also allows you to overwrite other properties if you wanted. Say, I'm going to add another one here, and so if I run this, I see that C over there. I think it's one of the best operators that there are out there, or one of the best combinations of operators that there are out there for TypeScript and JavaScript. And I think it's criminally underused. So what I have here is a bit more of a complex use case. This is what you would normally see more like a production environment. The object type I created is literally just the same type as the original object. Okay, the A1v1. It's just a utility type to keep things a bit shorter. But the idea is that we're grabbing the object that we receive as one parameter, the potential other one, and we combine them. However, in a real case, you would likely already have this built inside the function. So instead of receiving it, that's a side effect, not really the best option. But normally you would be building the object inside this function and then returning it with extra stuff if that extra stuff should be added. As you can see, we have an optional object that does have a field inside it. We have another one that is completely undefined. So when we actually pass them to the function, we get the A1, right? All of that. So that's for the optional object A, but for the object B, we don't get anything. However, if we wanted, we could come here and not even spread the original object. Obviously, it's going to complain, TypeScript, that's fine. But as you can see, it doesn't even spread it if you don't want to spread it. So this is a very fast and easy way to just manipulate objects at will, depending on conditions that you want to apply to them. That I think is much faster, much simpler than just adding if statements everywhere. If you want to incorporate this to your toolbox, feel free. And if you want to suggest any other names other than conditional spread operator, I'm all ears. More than happy to hear what you guys come up with. That's going to be it from me. So with that said, remember to think, design, and then code. And of course, to have a life. I'll see you on the next one.